Analysis of up-to-date methods of non-destructive testing of performance properties of reinforced concrete building structures. At present, the most used material in the production of building structures in concrete, being reinforced with steel rods, the so-called reinforced concrete. In the course of operation of such facilities, inevitably there arises a need to monitor the technical condition of a facility as a whole and its structural elements in particular. The main quality figures studied in the process of building structural survey of reinforced concrete structures are concrete density and compressive resistance. The condition of a reinforced component of reinforced concrete, reinforced steel net, rolled steel bars, etc. It evaluated not from the point of view of the qualities of reinforced itself. It is assessed based on the behavior of an element under study as a whole. Therefore, during the building structural survey of reinforced concrete structures, namely reinforcement, two particular problems are considered: concrete reinforcement and its condition. As was said earlier, while examining the technical condition of the operated reinforced concrete structures, various methods can be used. According to their approach, they are divided in two groups: destructive and non-destructive testing methods. The first group of the methods is based on the removal of reinforced concrete structure of its separate part from the general structure of a building structure in order to conduct further tests under laboratory conditions. In its turn, sample taken in the application of destructive methods of quality control of reinforced concrete structures is carried out by two cutting out samples from reinforced concrete structure working in a final design position, drilling out cores from a part of a structure. Method of destructive testing make it possible to determine concrete qualities in the operation structure with high accuracy. However, these methods also have a number. Removing a sample or several samples from a structural element, there also occurs an integrity disturbance of not only an element itself, but also a part of a facility's structural layout, since the supporting structures are usually interconnected with each other. Therefore, when one of them weakens, the load are redistributed. Another disadvantage is a violation of the experiment purity, when only part of a structure is used on the test. In fact, when culling cores or cutting out concrete samples from a body of a structure, a new independent structure, the methods of reinforced concrete structure survey that partially or completely solve the problems of destructive testing are non-destructive methods. Non-destructive testing methods of concrete quality include those that determine the strength characteristic of materials using local physical actions. These methods include impact pulse method, detachment method, chipping method, pressing method, method of detachment with chipping, elastic rebound method. The above mentioned methods are, in part, similar to destructive testing by wear effect. However, since they have only a local application in the structure, they don't significantly affect in performance properties. Another group includes non-destructive testing methods, being called indirect ones. By definition, indirect methods are those that allow us to determine the strength characteristic of concrete based on previously established dependencies. As a rule, these methods use the relationship between the compressive strength of concrete and the strength property which was previously determined by destructive or non-destructive methods. However, it's much more convenient to classify methods of non-destructive testing by their physical impact on the reinforced concrete element, as well as by the tasks they perform during the building structure survey. Among other methods of non-destructive testing of concrete and reinforced concrete structures, methods of local destruction are more often used during the building structure survey. At the core of each of the three methods of local destruction in the identification of concrete strength characteristic thought the internal resistance of a material to the detachment of its parts. Out of the three methods of local destruction, the method of detachment with chipping is the most widely used. In practice, in detachment the maximum force applied to tear off the part of concrete surface of the structure under study. Specifically, these methods differs in the way of attacking a device to the surface of a test sample. To perform the study, a hole is made in the prepared surface of a sample. Then a special leaf type and core of a device is inserted. A spacer is provided between the supporting studs of a device installed on the edges of a studied area of a structure, and the movable part of the device connected to the anchor inside the structure. During mechanical action, the anchor is tensioned inside the structure that pulls its part. The monitoring device records an increase in applied force. The process continues until the device shows a sharp decrease in the pull-off force, which will mean a partial destruction of the structural material in the anchor attachment area. Chipping a rib is the third method of local destruction once. Currently, there are two ways to perform tests in accordance with these methods. They depend on the types of research devices. The first one is used for structures made of concrete, reinforced concrete, that have more than one adjacent face. In this case, the device is attached to a structure by the type of a champ, being fixed on both sides of a structure. When, throughout a manually driven mechanical device's element, a load is applied at an angle to the surface of a measurement area. The device determines the growth of the applied force until it sharply decreases, which, as in previous methods, indicates the detachment of a part of a structure. The methods of local destruction have minor difference in the way of application, but they have advantages and disadvantages. Besides, they have a different range of applications, depending on the unlimited strength of concrete of which the structure under study is made. One of the most common methods that are used to determine the strength characteristic of concrete are impact action methods. The methods of impact pulse, elastic rebound, and plastic deformation are based on the principle of determining the concrete strength throughout impact pulse action on it. The basic principle for each of the above-mentioned methods of impact action is the principle of interaction of pulse being delivered by the impact the device's striker and structure material. For example, rebounding velocity is higher in concretes of higher density and lower contact of kinetic structure. The conversion of structure's kinetic energy into potential energy allows us to make calculations and build calibration dependencies between the readings of a device and the strength of concrete. The essence of elastic rebound methods are measured to the return velocity, rebound velocity, of the device's special striker and the height of rebound, based on a number of measurements carried out by the devices. The calibration dependence of the return position, height of a strike, and concrete strength is constructed. When constructing the dependencies, corrections for the position of a device are taken into account, since its deviations from normal to the surface of the structure affect the rebound velocity. A distinctive feature of the impact pulse method lies in a way of determining a relationship between the pulse and the strength of material that is subject to mechanical impact. The electromechanical converter receives a signal about the energy of mechanical impact on the concrete surface. In other words, the potential energy of a striker is converted into kinetic energy when it is transferred to the particles of material and partially returned to the potential of the same striker during the rebound. In this case, the device directly measures the pulse energy at the moment of impact, obtained in the form of the electrical signal. The advantage of this method over the elastic rebound method is the possibility of allowing vertical deviations from the plane of the concrete surface, while maintaining the purity of the result. The essence of the third impact action method, plastic deformation, consists in the constructing a relationship between the size of deformation imprint on the sample and its strength. With the help of a device, a spherical structure strike on the material of a structure, as a result of which a deformation area is formed in the testing plane. Having an idea of the magnitude of a plate force on impact, the hardness of the strike material and the overall dimensions of defect obtained on the plane of a structure, a relationship is built. It implies the following principle of strength determinations. If the striker leaves a deeper and large mark on surface from the impact, the less dense the material is. Based on this principle, the strength characteristics of concrete are calculated. A separate area of research related to the non-destructive testing of concrete and reinforced concrete structures is determined by ultrasonic methods. They refer to the type of indirect impact methods. The principles of ultrasonic methods operation are determined by the task that they face. One singles out surface measurement, through measurement and angular measurement. In surface measurement, the sensors of a device are located on the side of a structure, so the sound wave passed in the body of a structure in an arc from one sensor to another. The angular and throughout measurement are almost similar to each other, with a difference in the location of sensor. In the first case, they are located in adjacent faces of a structure, in the second one in opposite faces. The latter method of measuring the velocity of ultrasonic waves is more accurate, since ultrasonic passed throughout the entire thickness of the material of a structure. The application of ultrasonic methods for evaluating the strength of concrete is common in practicals. However, it also requires the construction of calibration dependencies. This is primarily due to the heterogeneity of concrete. The use of ultrasonic methods is not limited to the task of determining the strength of concrete in building structures. The future of ultrasonic devices and the very principle of methods worked allow us to solve such problems as detecting voids and defects of the body of a concrete structure, determining the location of the reinforced bars, continuous monitoring of building construction states, analysis of up-to-date methods of non-destructive testing of performance properties of reinforced concrete building structures. At present, the most used material in the production of building structures